On top of that piece of paper, write the word compound inequalities. Compound inequalities. Compound inequalities, children. Oh, I'm just going to leave it like that. I can't change it. When you have compound inequalities, you have two choices, boys and girls. You've got, it's either a and compound inequality or an or inequality. And they are slightly different. For the and compound inequality, both of them have to be true for it to be a real answer. Okay? It has to be for both of them. This 3, okay, fit this one because it's greater than 2, and it fit this one because it's less than 8. Okay? Now, rather than writing it out like this all the time, sometimes the book does that. Sometimes they put it all together in one small form, and it looks like this. Rather than writing it all out like that, they take the x and put it in the middle. They put the small number on the left out here. They put the big number on the right over here. And for these, listen very carefully, you don't have a choice which way the sign goes. For compound inequalities that use the word and, they always have to be this way. Always. This is the only time you'll have a number on this side of an x when you see a compound inequality. And when you see this, you don't read it as it looks, you read it like it is written out like this. If I see this on a book or wherever, I read it like this. X is greater than 2 and x is less than 8. Okay? That's only for the end. The ors don't get done like that. But if you see something like that, okay, x is greater than 2 and x is less than 8. And the only way to show the answers to this, because there are all these other little infinity things that those boys were trying to throw out there at you, the way you show the answer to that is you graph it on a number line. Shoot, I ran out of space. What can I do with it? I'll just do it down here. You graph it on a number line, and it couldn't be any easier. There are always going to be dots for this and a dot for that. At 2 there's going to be a dot, and at 8 there's going to be a dot. And here's the deal. If it's a compound and inequality, you color in what's in between them, because that's where the answers were. Remember, it was 3, 4, 5, 6, and 7. Those would all fall right here. It doesn't get any easier than that for graphing and compound inequalities. Okay. The only thing you have to be careful with is this. If there's an equal sign there, this is a colored in circle. If it's not equal sign, it's an open circle. So watch how difficult an and compound inequality is. -4. If I asked you to read this compound inequality, how would you say it? Who wants to take a stab at it? Sammy?
X is greater than or equal to -4.
And?
X is
Less than.
or equal to.
Right. X is greater than or equal to -4, and x is less than or equal to 3. Graphing it is no more than this. Here at -4, it's colored in because it's equal. Here at 3, it's colored in because it's equal, and you color in what's inside of it. Not very hard. Not very hard at all. Now, guess what happens with the ors? Yes, they're what you paddle boats with, but not in this case. I kind of ran out of them. I'm going new page here. What was it? What was my problem there? X what? X was, what was the one I gave you?
The one you just did.
Yes, the one that's just back here. The other one, but 4 and 6.
Yeah.
X is less than 4 or X was greater than 6. There is no way to combine that. If it's an or compound inequality, it's going to look like that. It's going to be two inequalities with the word or in between it. You can't shorten it, put it together there. If you remember, the answers to this we gave were 3, 2, 1, blah, 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 blah. The answers we gave over here are 7, 8, 9, 10, blah, 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 blah. When it is an or inequality, when you graph it, the same thing is true. There's going to be a dot at 4, and there's no equal sign, so it's an open one. There's going to be a dot at 6 equal to. But or inequalities don't go converge in, they go opposite ways, okay? Because it's anything that goes this way. And there are some exceptions to that, but for the general everyday problem there, that's the way it's going to look. Hello. I should turn that off, but it's too far to walk. Alright? But you still have to be careful with it. Let's say I've got x is less than 1 or x is greater than 3. It's just as easy. Well, let's put an equal sign under this one. X is less than 1. Here at 1, open circle shoots off this way. X is greater than or equal to 3. Colored in circle shoots off that way. Difference between and or, ands come together, ors go the opposite way. Now what might happen every once in a while is somebody might try to trick you and they'll give you something like this. X is less than 4 or x is greater than 3. What's going to happen there, Jake? Let's look. If you graph this, here's what you might tend to think is going to happen. 4, open circle, 3, open circle, and they go in opposite directions. But if you look at that inequality, what does this say? X is less than 4. It goes this way. X is greater than 3. It goes this way. And in the end, if I asked you to give me a number that was less than 4 or greater than 3, what is less than 4 but greater than 3? Give me a number that's less than 4 or greater than 3.
3.
You can't be wrong.
3.
Every number is less than 4 or greater than 3. Right? Because it's an or. Any number greater than 3 means starting at 3, any number bigger than it. Any number less than 4 starts at 4, goes less. It's not the colored in middle, it's all numbers everywhere that fit that. Yes, that's it. We're so clever. There. I was going to say open your books. Take out your homework piece of paper there. So looking at the two